So right now I want to talk about section 5.2, which is inverse functions. Just want to give you a couple of simple examples. I'm going to do 3, 9, 13, 15, 21. So the main ideas here are one-to-one, horizontal line test, and inverse functions. And I'd like for you to work through examples 1 through 3 in the book. Alright, so I'm going to give you kind of a technical definition of one-to-one, and then I'll give you the horizontal line test, which will maybe give you a more graphical interpretation of one-to-one, and then we'll do an example of that, and then we'll do an inverse, an example of that. So I'm going to say that a function f is one-to-one, and we often write this just 1-1, if for every x not equal to x prime, we have f of x is not equal to f of x prime. That is, each output is unique. Okay, so we know that for a function, every input has a unique output. That is, there's not like f of 1 could be two different things, right? But what we don't know about, that's just the definition of a function. But we don't necessarily know is, does every output have a unique input? So let me give you a one-to-one function passes the horizontal line test which we call HLT, if no horizontal line touches its graph more than once. So it's like the vertical line test, except with horizontal lines. So in order for a graph to be the graph of a function, it has to pass the vertical line test. In order for that function to be one-to-one, it has to pass the horizontal line test. So like I said, let's do a quick example. Let's let f of x equal x squared, and here we've got f mapping reals to reals. Well, we've seen about infinity times in this class the map of the graph looks like that. Now if I have this horizontal line, it's fine, touches the graph 0 times. This horizontal line touches the graph 0 times. The x-axis touches the graph exactly once, not a problem yet. But as soon as I look at a horizontal line above the x-axis, I know that I touch the graph more than once. So it fails the horizontal line test. So this function is not one-to-one. Okay, now let's look at g of x, which is x cubed. And x cubed is going to look like this. And every horizontal line that I can come up with touches this function exactly once. So passes horizontal line test is one-to-one. Okay, so it's just a couple of quick examples. So now on to the next definition. A function g, just having a hard time making that g, is the inverse of a function f if and only if, remember that's IFF, if and only if, f of g of x equals g of f of x. Now this happens for all x in the respective domains. Again, I've told you I'm kind of dusting under the hiding some dust under the rug about the domains and ranges of things, where I'm trying to not get too involved about the domains. Let me do a quick example So let's let f of x equal 3x minus 2 over 4. And let's let g of x equal 4x over 3 plus 2. Is that how I want to do this? How's that going to work out? I think I want to do x plus 2 over 3 actually. So let's do let me actually do a simpler example. I had a more complicated example planned, and then I chickened out at the last minute and decided to do a simpler example. So now I'm going to do an even simpler example. Let's do 3x plus 1 and g of x equals x minus 1 over 3. So when I compute f of g of x, this is f of x minus 1 over 3, which is 3 times x minus 1 over 3 plus 1, which we cancel out the 3's. We get x minus 1 plus 1, which is x. Looking good so far. G of f of x, then, is g of what? G of 3x plus 1. And this is going to be 3x plus 1 minus 1 over 3. Well, I've got plus 1 minus 1. And that's 3x over 3. Those cancel. And again, I get x, which means these are inverses. We write, oh, I didn't tell you, we write g equals f inverse. So f raised to the negative 1 power. That's how we indicate inverses.